Hi guys, this is the next video, Traditional and Modern Release Management. In the last video, we looked at what is DevOps. In this video, we're going to take a look at life cycle of a project. We will also see chain of communication and cost of fixing bugs. We will also see modern release management. Through the years, companies have pushed the development of their IT systems out of their business core processes. Retail shop business was retail and not software, but reality has kicked in very quickly with companies such as Amazon or Alibaba, which can partially attribute their success to keeping their IT systems in the core of the business. A few years ago, companies used to outsource their entire IT systems, trying to push the complexity aside from the main business in the same way that companies outsource the maintenance of the offices where they are. This has been successful for quite a long time, as the release cycles of the same applications or systems were long enough to be able to articulate a complex chain of change management, as a release was a Big Bang style event where everything was measured to the millimeter with little to no tolerance for failure. Usually the life cycle for such projects is very similar to this flowchart. This model is traditionally known as waterfall, and it is borrowed from traditional industrial pipelines where things happen in very well-defined order and stages. Engineers tried to retrofit the practices from the traditional industry to software, which, while a good idea, has some drawbacks. Old problems are brought to a new field. The advantages of software being intangible are negated. With waterfall, we have a big problem. Nothing moves quickly. No matter how much effort is put into the process, it is designed for enormous software components that are released few times a year or even once a year. If you try to apply this model to smaller software components, it is going to fail due to the number of actors involved in it. It is more likely that the person who captures the requirements won't be involved in the development of the application and for sure won't know anything about the deployment. Even though this is a better approach, it is not exempt from problems like some details are hard to capture in diagrams. People in the business, stakeholders, do not understand UML, and creating diagrams requires time. Particularly, the fact that business stakeholders do not understand UML is the big problem here. After the capture of requirements, changing them or even raising questions on lower levels requires involving some people, and at least one of them does not understand the language of where the requirements were captured. Now we will see cost of fixing bug. Once we've made it clear that we have a communication problem, bugs are expected to arise during our process. Either a misalignment with the requirements or even the requirements being wrong usually leads to a defect that could prevent us from deploying the application to production and delay everything. In waterfall, fixing a bug is increasingly possible in every step we take. For example, fixing a bug in the requirements phase is very straightforward. Just update the diagrams or documentation, and we are done. If the same bug is captured by a QA engineer in the verification phase, we need to update the documents, diagrams, create a new version of the application, and deploy the new version to the QA environment. Now, we will move to agile development and communication. In the traditional release management, one of the big problems was the communication. Chains of people passing on messages and information, as we've seen, never ends well. Agile encourages shorter communication strings. The stakeholders are supposed to be involved in the software development management, from the definition of requirements to the verification of the same software. This has an enormous advantage. Teams never build features that are not required. If deadlines need to be met, the engineering team sizes down the final product, sacrificing functionality, but not quality. Deliver early and deliver often is the mantra of Agile, which basically means defining minimal viable product and delivering it as soon as it is ready in order to deliver value to the customers of your application, and then delivering new features as required. With this method, we are delivering value since the first release and getting feedback very early on the product life. In order to articulate this way of working, a new concept was introduced, the sprint. A sprint is a period of time with a set of functionalities that are supposed to be delivered at the end of it into production so that we achieve different effects. Customers are able to get value very often. Feedback reaches the development team every 2 weeks so that corrective actions can be carried on. The team becomes predictable and savvy with estimates. A story is a well-defined functionality with all the info for the development team captured before the sprint starts. So once we start the development of the sprint, developers can focus on technical activities instead of focusing on resolving unknowns in these features. Not all the stories have the same size, so we need a measurement unit that is the story points. Usually, story points do not relate to a time frame, but to the complexity of it. This allows the team to calculate how many story points can be delivered at the end of the sprint, so with time, they get better at the estimates and everybody gets their expectations satisfied. At the end of every sprint, the team is supposed to release the features developed, tested, and integrated into production in order to move to the next sprint. The content of the sprints are selected from a backlog that the team is also maintaining and preparing as they go. The main goal is to meet everyone's expectations by keeping the communication open and be able to predict what is being delivered and when and what it is needed for it. In this video, we've looked at traditional and modern release management. In the next video, we will see DevOps and microservices.